Welcome back, mathematicians. What we're going to do is start with a new section. It's going to be sequence and series. So, of course, we'll start with sequence, right? A sequence, here's our definition here. A sequence is going to be an ordered list of terms. So, in other words, it's going to be a list of things that it's going to be in some kind of order, right? And in this case, we have 5, 10, 15, 20, 25. With this being our first term, right? This is our second term, third term, fourth term, and fifth term, okay? So what we should first notice is that to get from one term to the other, we're just adding 5, right? Add 5, add 5, add 5, add 5. Next, we should know that I don't have to depend on the previous term to get my 10th term or 12th term or anything like that. I can just multiply like the position that we're in times 5, and that would give us our next term, right? So in this case, 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20, and 5 times 5 is 25, etc., etc., etc. So that'll be important later on to us when we start talking about series and how to sum these things together and how to look for specific terms. So for now, let's talk about the definition of series. It's going to be the sum of a sequence. So we're going to take our list and we're going to add them together. There's two ways I could do that. One of them is going to be finite, right? So a finite series, in this case, it has 4 terms only, and we stop the pattern after the 4th term. So first, second, third, fourth. I have, and we can write it in summation notation, right? So 2i is going to denote like the pattern, right? So in order to get like the 5th term, right, I multiply 2 times 5, and the 5th term would be 10, right? So in this case, the sum, this is a sigma, the sum from the first term to the 4th term of 2i, right? So I take my terms, 2 plus 4 plus 6 plus 8, and that would give me 20, okay? Next, I'm going to look at an infinite series. So an infinite series goes on and on and on and on. In this case, I took the original original sequence that we had before, and I turned it into a series, right? So instead of just commas, now we have additions in between, and we can denote that with this summation, right? I have, again, think of this as a list of instructions here, right? This is add everything up from the first term to infinity of this pattern 5 times whatever position it is, right? So instead of having a finite position, right? So this one only goes to the 4th term. I go all the way to the infinite term, I guess. Another thing we have is going to be arithmetic sequence. So we're going to use this formula to figure out what any term is, right? So we can take the nth position, nth term, and combine it with the first term and what's called the common difference, right? So we're going to call this the common difference. And we are going to figure out whatever nth term. So let's take a look at an example. This guy, 3, 8, 13, and 18, right? The pattern being is that I'm adding 5 to each of these. So 3 plus 5 is 8, 8 plus 5 is 13, 13 plus 5 is going to be 18. Write the explicit formula for the sequence. So I'm going to talk about the general formula, right? So we took that formula from before. Again, flip back to your notes if you don't remember. First thing I want to do is find the common difference, right? So I take 2 of the terms, let's say 8 and 3. 8 minus 3 is going to give me 5. Then I look at a different set of terms. 13 minus 8 also gives me 5, right? And 18 minus 13 gives me 5. So we see that we have a common difference here, right? So that's our common difference. it's going to be 5. So I'm going to write a formula in terms of that. So for any term I have, right, a to the n, whatever term I want, I start with my first term, 3, right? That's a to the 1. This is my a to the 1 right here, plus n. I don't know what that is yet, so my nth term, or some, yeah, plus 1 times, well, I found my common difference. That's 5. So this is d, and that's just a to the n. Okay? So what I could do with that is I can find any term. So say I'm tasked with finding the 11th term. No problem. I have a sub 11. So the 11th term of my sequence is, I'm going to start with 3 plus n. Oops, sorry, not n. 11 this time. It's 3 plus 11 plus 1 times 5, right? And then I just do order of operations. So 3 plus 12 times 5. 3 plus 60. So that guy is going to be 63, right? My 11th term for this sequence is going to be 63, right? I didn't have to sit there and add 5 plus 5 plus 5. I know my 63rd term, or sorry, my 11th term is 63, right? Let's take a look at another example. So in this case, I want to write the series in summation notation. So I have a fixed series here, or a finite series, right? I'm not going infinitely long, and I want to turn it into summation notation. Not a problem, right? So first thing I have to look for is a pattern, right? In between these two things, I have to get add 4. So add 4 and check again. My common difference again, 12 minus 8, that's 4 again. 16 minus 12 is add 4, right? So my common difference is 4 in this case. But then I want to kind of change my thinking. When I'm thinking of summation notation, right, I have to think, well, if I'm in the first position, what do I have to do to 1 to get 4? Well, I multiply 4 times I. Let's try it out. So 4 times my first one gives me 4. That works. 4 times my second position, right? 4 times 2 is going to give me 8. That works out. 4 times my third position gives me 12, etc., etc., etc. Right? So we might have to add something to this to get it to work, or something like that. And that does happen. It's not a problem here. So this guy goes to the 5th term, right? 1, 2, 3, 4, 5. So since I go to my 5th term, I go from my first term to my 5th term, and there you go. You're done. Okay. One other note on your assignment, there's going to be a part that says for each of the sequence state if it is arithmetic, geometric, or neither, right? So in this case, in this section, you're looking to see if you're either adding or subtracting. In fact, subtracting is kind of a version of adding. So if you're adding or subtracting, that's going to be arithmetic. If you're multiplying, that's going to be geometric. If you're doing something else, that's neither, right? So we're just going to talk about these 3 cases for right now. Arithmetic, again, plus or minus, geometric, multiplication or division, and neither if it's neither one of those. Okay, so for example, 4 is plus 20, plus 20, plus 20, plus 20. That's going to be arithmetic. Okay, thanks for listening. I'll see you in the next video.